Even though you're making a video game, you still might want to roll a physical dice cube. Nice. We can determine which side faces up using the dot product. So whether you're rolling a single d6 or a bunch of different sided dice all jumbled together, this system is computationally fast and relatively easy to set up. Let's dive into Unity and set up a practical example. If you'd like to follow along with this tutorial step by step, all that you really need to know and set up for now is some sort of base collider for your dice cube to actually roll around and bounce on, and then some sort of dice cube model itself. I'm using this asset here, but you can really use just about any dice cube model that you can find. I'll make sure I leave a link to the asset that I'm using in the description down below. The other thing worth mentioning is that I also have 4 different walls and a ceiling, each with their own box collider, which is really just a ProBuilder shape with the mesh renderer hidden, just so our dice cube doesn't bounce out of the surface and fall off the screen. But outside of that, I've got a pretty empty Unity project that we can work with. Inside of our project, let's go ahead and create a scripts folder, and inside here, let's create our first script. I'll go ahead and create a monobehavior script, and let's just call this die. Not that I'm trying to murder my dice cube, but just the singular version of a dice cube, or die for short. Let's actually implement a little bit of logic to just get it bouncing and rolling around our scene. To do that, we can actually just use the Unity physics engine. So on your dice cube, just make sure that it has a box collider completely encapsulating the dice cube itself, as well as a rigid body with just the default values set up. Before we open this up, let's actually just go ahead and slide on our die component directly to the dice cube itself. With that attached, let's go ahead and open up the class. Let's first cache a reference to our rigid body. I'll just call this _rigid body. And in Awake, let's go ahead and grab a reference to that rigid body using getComponent rigid body. For now, to keep things simple, let's actually just go ahead and detect whenever our user clicks the left click mouse button, and then we can actually just apply a little bit of force to our rigid body. So let's go ahead and detect that in Update. To keep our input simple and not get overly convoluted for this tutorial, let's just use the shorthanded new Unity input system for now. And we can just say if mouse.current.left button was pressed this frame, then we can actually execute our logic. For now, let's just create a method that we're yet to create called roll dice. And we can go ahead and create that as its own separate method. Inside of this method is where we can apply some force to our rigid body. To do this, we can use 2 built-in Unity methods called rigidbody.addForce and rigidbody.addTorque. But to do that, let's first define 2 different vector 3s to properly execute that logic. I'll define my first vector 3 called force, and we'll set that equal to a new vector 3, giving that the direction that we want to fling our dice cube. Now, I don't really want it going in the X or the Z axis, but I do want to apply some sort of force directly up in the Y axis. Let's make sure we create that variable as a serialized field so we can actually modify it back in Unity. Let's just go ahead and create the default value as something like 5F for now. While we're at the top of our class, let's create another serialized field as a separate float called torque. And we can use that down below in our second vector 3. Let's just also go ahead and initialize that to 5 for now, and we can tweak those settings once we're back in Unity. Back in our roll dice method, let's define another vector 3 called torque. We can define torque as a new vector 3, and then we actually want to randomize the direction that the dice cube is rotating every single time we fire this function. So for that, we actually need to randomize both the X, Y, and Z values. I'll just use random.range and then randomize it in between -1 to 1 for every single direction. We'll just go ahead and copy and paste this a couple different times for the Y and the Z values as well. Now that we have the random direction, we can actually just times that entire vector 3 by our torque field up above. Now that we have those 2 vector 3s defined, we just need to actually apply the force to our rigid body. So let's go into our rigid body and say .addForce, passing through force as well as the type of force mode that we want to use. In our case, let's just use force mode.impulse to apply a quick little punch to our dice cube. Next, let's go into our rigid body and add a little bit of torque. So .addTorque, and then just passing through our torque as well as force mode.impulse once again. Nice. Before we get any further, let's pop back into Unity and make sure everything is working as intended so far. Let's go ahead and hit play, click the left mouse button, and there you go. We've got our dice cube properly being flung around our screen. Now that we have the physics of the dice cube set up, how can we actually detect which side is facing up? Now, you might think of an approach where you could attach a bunch of different tiny sphere colliders to each individual side of the dice cube and detect which side is facing up like that. Maybe you've considered firing a raycast from the dice cube in a specific sort of direction and computationally getting which side is facing up like that as well. But I think there's an easier approach using the dot product. In math, the dot product measures how much 2 vectors are pointing in the same direction, either using Cartesian coordinates or the trigonomic approach. But luckily, Unity simplifies this approach for us using the vector3.dot method. If we normalize our vectors, meaning that we're scaling to a magnitude of 1 while still maintaining the same direction, comparing two vectors will always return a value of in between -1 to 1. Meaning that if two vectors are pointing in two opposite different directions, say up and down, we'll return a value of -1. If two values are perpendicular to each other, we'll actually return a value of 0. And if two vectors are compared, pointing in the exact same direction, we'll return a value of 1, and every value along the way if we need to. But keep in mind that if two vectors are compared at a 45-degree angle, we won't actually return a value of 0.5. And that's because the cosine function doesn't actually scale linearly with the angle. If we need to return a value of 0.5 for whatever reason, it's actually at 60 degrees. So with that greater understanding of the dot product out of the way, let's dive back into Unity and continue our tutorial. Let's go into our D6 game object and create an empty game object that we'll just call sides. Inside of sides, we want to create 6 different empty transforms. So I'll go ahead and create an empty, and I'll just call this first side 1. We want to duplicate this 5 more times so that we have 6 sides total. We just want to rename each side inside of our hierarchy to 1, 2, 3, 4, 5, and 6. Next, all we need to do is just make sure the orientation of each individual transform is just pointing towards the side of the side that it's representing. Just make sure your scene orientation is set to local. So for the side 1, we want this to point up, meaning we need to rotate it on the x-axis by 90 degrees. Going over to side number 2, great, we can actually see that's already pointing towards the side number 2. Number 3, let's go ahead and find this bad boy. We need to rotate it 90 degrees on the Z, I believe. It might be 90 degrees. There we go, 90 degrees. And number 4, let's go ahead and find number 4, rotating it -90 degrees. Great, facing the right way. Number 5, where is this guy? That is right here. This time rotating on the Z 180 degrees, and then for side number 6, there you go on the very bottom, we just need to rotate it on the x-axis 90 degrees one more time, except in our case it'll be -90 degrees. You don't need to fiddle with actually moving the transform itself, because we're only concerned about the direction that the local orientation is pointing on each individual side of the dice cube. With that set up, let's hop back into our die class. And we just need the transform itself out of each individual side. So let's create an array of transforms for each individual dice side. At the bottom of the class, let's create a method to detect which side of the dice cube is actually facing up. So for now, let's just create this as a void called getSideFacingUp. What we can do is we can go through each individual transform of each individual side and use the dot product to get the side that's facing the most up. So at the top of the method, let's cache a reference to a transform that we can call upside, and we'll just initialize this or set this to null to start. Once we go through each individual side and get the dot product of each individual one, we can set the upside transform to the side that we actually want to return. We can also do the same, caching a reference to the side that has returned the maximum dot product so far. So let's just go ahead and call that max dot. And here's where we want to actually iterate over our dice sides array. So we can just do that using a for each loop. We want to iterate over our dice sides array. We can just go ahead and call each individual iteration side, and we can go ahead and explicitly pass through our transform type. But here's where the magic actually really starts to happen, and we can actually use the dot product for each individual side. We can go ahead and call this float dot and set that equal to the vector3 dot dot with a capital D, passing through the side dot up, which is always going to be the green axis of the transform in world space, but the local orientation we know is going to actually be getting tossed around our scene, and always comparing it with vector3 dot up, which is going to be world space for just always pointing up. Meaning that when we compare the two, we'll always return a value of somewhere in between -1 to 1. And here's where we want to check. If dot is greater than max dot, well, then we just want to set max dot equal to dot, as well as upside equal to this iteration of side. Now we are getting a little bit of a compilation error saying, hey, we haven't actually initialized max dot to anything. So we could just go ahead and set it to -1. And Rider is also giving us a little bit of a hint to just invert the if block, which I actually do prefer this syntax here, saying if dot is not greater than max dot, then just continue this iteration. And if it is, go ahead and set max dot equal to dot, as well as upside equal to side. And for now, whenever we fire this function, let's just go ahead and debug.log upside.name. And even though we know that this is never actually going to be null, we can just do a little bit of a null reference check and say if upside is equal to null, then return, just to get rid of our warning compilation. Now, before we pop back into Unity, we actually have to fire this method somewhere. Now, I think this is going to be a little bit wonky, but for now, let's actually just fire it directly in Update. Let's pop back into Unity and see what this looks like. On our die component, we can actually just lock this in the inspector, highlight all 6 of our sides, and then just drag this into our dice sides array. Let's go ahead and press play and see what happens. There you go, mission successful. We've already got 1 printing to the console, 1 being the side that's already facing up. If we left click over in our game window and get our dice cube flinging around, there you go, working as intended. Even as it's in the air, you can actually see it changing every frame as soon as one side is facing more up than any other. But we don't necessarily need this firing every frame. So when can we actually call this function? Well, the rigid body component on our dice cube actually has a nice built-in Unity method called isSleeping. That's only actually going to fire if our rigid body isn't currently being affected by the physics system, meaning that it's not actually currently being affected either by outside forces or itself in any way. Let's hop back into our die class and rig that up properly. But because we're dealing with the physics engine, let's make sure that instead of using update, we're using fixed update. We can actually just check if rigid body.isSleeping, then and only then do we actually want to fire this get side facing up function. Now we're not quite there yet because this would still fire each individual frame that the rigid body just isn't moving. So let's take it one step farther and introduce a bool up top called isRolling. And we'll just initialize that to false to start. That way we can actually set isRolling to true when we actually roll the dice. And at the very end of get side facing up, we can actually just go ahead and also make sure that isRolling is set to false. With this bool created, we can actually just do one more little insurance check and say if rigid body is sleeping and is rolling, then go ahead and execute this get side facing up logic. Let's pop back into Unity and make sure everything is working as intended. And if everything is working correctly, once we actually fling our dice cube and roll our dice, it should return the value of 4 and only for that specific frame as soon as our dice cube stops rolling. But what if you actually wanted to have more than one specific dice cube? Let's say you wanted to have 2 dice cubes, or 3, or 4. Well, how can we actually return the sum of all the dice cubes being rolled on screen? At the moment, we're actually just printing a string reference to the console, so we need to actually make sure we're changing that to an int, and then actually introduce some logic to return the sum of all the dice cubes actually being rolled. To do that, we need to actually create one more script. In our scripts folder, let's go ahead and right-click and create another MonoBehavior script, and we'll just call this one our dice manager. Let's go ahead and create another empty game object to our hierarchy. We can just go ahead and call this dice manager and attach the dice manager class as a component to our game object. Inside of our dice manager, let's go ahead and get a reference to all of our dice currently being rolled. So let's just create an array that we can actually store all of our dice cubes being used. And we can just go ahead and call this _dice. Now for our sake, I think it makes a lot more sense to actually move the input that we previously had in our die class over to our dice manager, and then we can just roll all of the dice at once. So let's actually just go ahead and grab this entire update function and actually just move it over to our dice manager class. We just need to make sure that we're actually using the input system namespace up top, and then create a roll dice method in this specific class. Except I think in our case, it makes a little bit more sense if we call this something like roll all dice, because we have a roll dice method in each individual die. All we need to do now is just iterate over each individual dice cube and just roll that specific dice. So let's do that with another for each loop. We just want to iterate over our dice collection. We can call each individual one die, and we can explicitly declare the die type. Inside of each individual die, well, we just want to roll the dice. So let's actually change roll dice from private to public so we can actually call that from our dice manager. With that public popping back over to our dice manager, we can just say die.roll dice. Great, nothing too complicated so far. Next up, let's create some sort of method where we can return the sum of all the dice cubes combined and then actually just print that entire sum to the console. So to keep track of that, let's create an integer up top that we can just call _total sum, and we'll set that to 0 to start. Let's just call this void on die stopped. And let's pass through an integer called result that we can actually add to that sum. So we just want to take total sum plus equals result. And instead of printing to our console inside of our get side facing up function over in our die class, let's actually go cut that out, pop back over to our dice manager class. Let's actually just print something to the console that prints the total sum each individual time a dice cube stops rolling. But where do we actually want to call this method from? I suppose we could get a reference to the dice manager in each individual die and then actually just call this method as a public method from our die class, but that already seems a little bit messy. Let's actually go ahead and create a public event over in our die class for when each individual die stops rolling, and then we can actually just subscribe to that event over in our dice manager. At the very top of our die class, let's go ahead and create a public event using an action. And since we passed through an integer as a result over in our dice manager class, we need to also pass through an int in our public action over in our die class. And we can call this public action our onDieStopped event. Now, before someone inevitably in the comments says, well, actually, Steven, an action in C# isn't actually an event, it's actually a predefined delegate, just hold your horses. Perhaps I'm using the jargon event a little bit too loosely. If you'd like to leave a comment down below, roast me on literally anything else. Now, if this syntax is new to you, I'll make sure I leave the links to some Unity documentation and videos if you'd like to explore using Unity events or delegates in C# a little bit further. With this event created, let's go ahead and invoke this event inside of fixedUpdate when we actually calculate which side is facing up. But to do that, we need to do a little bit of refactoring. We can say onDieStopped.invoke, passing through the result of each individual dice cube so we can actually properly hook into that result in our dice manager class. To do that, we're going to need to refactor our getSideFacingUp method just a little bit, where we can actually return an int, and we can just call that result. Now over in our getSideFacingUp method, instead of returning void, we just need to return an int. And down below, instead of returning void, we can actually just go ahead and delete this line entirely, and we want to return an int. But what do we actually want to return? Because at the moment, all we really have is a string reference. Well, in our case, we could actually just cheat a little bit and just parse this string reference to an integer because we know in our hierarchy, it's always going to be just named 1, 2, 3, 4, 5, or 6. We can actually just parse upside.name. And because we're still getting that little bit of a null reference warning, we can just go ahead and check the expression for null to make sure that we're never actually getting a null reference exception. And then to make sure we don't get a syntax error, let's just return 0 if all of these conditions aren't met. Let's just make sure we set isRolling equal to false before that ever happens. With this onDieStepped event now properly created, let's pop back over to our dice manager class and then just fire off the function onDieStopped every single time that event fires. In start, let's go ahead and just subscribe to each individual event. So once again, iterating over each individual dice, let's just go ahead and call each individual iteration die and declare our die type. This time, we just want to go into each individual die and subscribe to onDieStopped and tack on our onDieStopped dice manager method. Let's pop back into Unity and give that a spin. In our dice manager class, let's go ahead and lock this in the inspector and drop in each individual dice cube into our dice array. Let's go ahead and hit play and see if everything is working as intended. Left click, great, rolling each individual dice cube, and there you go. Every single time a dice cube stops rolling, it fires that event and returns the total sum at that time until all dice cube have stopped rolling. At the moment, you're able to just constantly spam the left click mouse button indefinitely, and we should probably create some sort of little flag check to make sure our player can only roll the dice cube if all dice have completely come to a stop and the sum has been properly calculated. Let's do something similar here over in our dice manager class that we did very similar to our die. Let's just create another bool called _isRolling, and we'll set that to false. In our update, let's not only check for input, but let's also check and make sure isRolling is set to false. When we roll all dice, we want to set isRolling to true. And somewhere over here in onDieStopped, when all dice have come to a complete stop, we want to set isRolling back to false, but only if no more dice are rolling. To do that, we just need a little bit more additional logic. At the top, let's create one more integer called dice still rolling. When we roll all the dice, we can set dice still rolling is equal to dice.length to get the length of the array. In our onDieStopped method, we can just decrease that value by 1 each individual time the method fires. So dice still rolling minus minus, great. And then just do one little bit of an if check and say if dice still rolling is equal to 0, then isRolling is equal to false. And I think it makes a little bit more sense to only return the value once all dice cubes have stopped rolling, so we can actually just slide our debug.log down into that if block. But to clean up our code, we can just invert this little if block to keep things all nice and clean. Nice, I think we're all set. Let's pop back into Unity and make sure everything is working correctly. Let's go ahead and give it a spin. Haha. No pun intended. With a value of 5, 11, deuce, and deuce, we have a sum total value of 15 printed to our console and only once after everything has actually come to a complete stop. But you'll notice, I missed one little bug. We just need to make sure that we're actually resetting the value back to 0 every single time we roll all dice. So right here in roll all dice, when we set is rolling to true, let's also just set the total sum back to 0 each individual time we roll all dice. One thing that's convenient with this system is you don't just need to use a D6. You can follow the exact same pattern and the exact same logic with things like a D4 or even a D10, a D20, and even though a D100 might be a bit ridiculous and it would take you a while to set up all the transforms, you could do that. You just need to make sure that the side that you're trying to detect, that the local orientation vector.up axis, or this green axis, is just pointing towards the face that you'd like to detect. You can even combine different dice cubes of different sides, and this system will work every single time. So whether you're just rolling 1 dice cube, 5 dice cubes, or even 100 dice cubes, it doesn't actually matter with this system because the dot product is always going to return the side that's facing the most up, even if it's on top of something else. Now you could continue building on this system however you'd like. You could even have some sort of dice side class with custom enum values, say something like for an attack side and a shield side or a defense side, or maybe some sort of ability dice cube, whatever you could really come up with. As long as you can actually detect which side is facing up, you can return that value. You could even take this entire system and overlay this camera on some sort of 2D art as well. If this video was helpful to you, hit the like button and consider subscribing. I hope to do more of these videos in the near future.